Okay, good morning to all of you. I welcomes to all in our lecture series on statistical mechanics, that is your core paper 14, belongs to 6th semester BSc syllabus. In our last class we have been discussed in detail about Planck's law of black body radiation. In detail we have been discussed, and we found the average energy of the oscillator with the help of Planck's hypothesis, that is your h mu by e to the power h mu by kbt minus 1. And we found the energy density in between mu and mu plus d mu, according to Planck's, it will be 8 pi mu square by cq into d mu into h mu by e to the power h mu by kbt minus 1. Here kb is nothing but your Boltzmann constant, and in the form of frequency it will be this one, 8 pi sc by lambda to the power 5 into 1 by e to the power sc by lambda kbt minus 1. So these two expressions, equation number 7 and equation number 8, represents the Planck's radiation law in the form of frequency and wavelength. With the help of these two equations, we are going to be derive all the classical uh, theories, whatever previously has been predicted or we have been discussed. Okay, so first of all, in this class we are going to be discuss this one. Okay, derivation of different laws from Planck's radiation formula. So first we are going to derive Wien's distribution law with the help of from the Planck's radiation law. We are going to derive Wien's distribution law. So here Planck's law is also called as the universal law because it is explained Wien's distribution law, Religion's law, and Religion's catastrophe itself, Wien's displacement law, and your Stephen Boltzmann law. Okay, so first we are going to derive Wien's distribution law from your Planck's radiation law. You can go back in your note and you can find that your Wien's distribution law is this one in the form of lambda, that is your E lambda d lambda is equal to A by lambda to the power 5 function of lambda t into d lambda. Okay, so that expression or equivalent to this expression we are going to derive with the help of Wien's distribution law. Watch carefully. I suggest that you have to pause the video and write down the note carefully also. From Planck's radiation law, we found that u lambda d lambda is nothing but your 8 pi sc by lambda to the power 5 1 by e to the power sc by lambda kbt minus 1 into d lambda. Let this is your equation number 1. This expression we found in our last class, this one. Okay, let here this is equation number 1. For shorter wavelengths, if we are going to consider for shorter wavelength or higher frequency, then you can see that when lambda is very small, if lambda is going to be very small, then e to the power sc by lambda kt, this term is going to be large as compared with 1. See, this lambda is small, so e to the power sc by lambda kbt will be large as compared with 1. That is 1 means this one can be neglected in comparison with this term. Then equation number 1, this equation number 1 will be u lambda d lambda will be equal to h pi hc, 8 pi sc by lambda to the power 5 into 1 by e to the power sc by lambda kbt into d lambda. Or it can be written as u lambda d lambda equal to 8 pi sc by lambda to the power 5 into e to the power sc by lambda kbt into d lambda. You just match this expression with your Wien's distribution law. This is your Wien's distribution law, that is E lambda d lambda. So here we found U lambda d lambda. So for this is belongs to unit volume. So if we are going to consider total volume, then it will be E lambda d lambda. So here you can see E lambda d lambda is this one, and if we are going to consider itself u lambda d lambda, u lambda and d lambda, if we are going to consider, so here you can consider that by equation number 1 e lambda d lambda. So equation number 1 here equation number 1 is nothing but e lambda d lambda is considered as u lambda d lambda in case of Wien's distribution law. So hence here e lambda d lambda or also your u lambda d lambda. So u lambda d lambda is nothing but your constant by lambda to the power 5, some constant by lambda to the power 5, function of lambda t into d lambda. Exactly same expression, similar type of expression we found. This is the constant by lambda to the power 5. Here I forgot to write lambda by lambda to the power 5. Here h pi sc, 8 pi sc considered a. So this will be u lambda d lambda equal to a by lambda to the power 5. Okay, a by lambda to the power 5, and here it will be e to the power minus b by lambda t. So this is nothing but your this one function of lambda t, right, into d lambda. Okay, so hence from Planck's radiation law we derive Wien's distribution law, but it is work in your shorter wavelength side well. Now we are going to be find out the Religions formula from Planck's radiation formula. Okay, now for longer wavelength, that is your when lambda is very large, then sc by lambda kbt is very small. It will be small value. Sc by lambda kbt will be small if lambda will be large. And if we are going to be expand this e to the power sc by lambda kbt, then it will be see 1 plus e to the power x. We know that e to the power x expansion 1 plus x by 1 factorial plus x square by 2 factorial, like this. Okay, so here we just consider that sc by lambda kbt as x. So if we are going to expand, then it will 1 plus sc by lambda kbt by 1 factorial plot sc by lambda kbt square by 2 factorial, and so on. Now hence higher order terms of this one will be very small, because when lambda is large this term is small. Okay, when if we are going to consider this one, then denominator will be lambda square. That means this term will be again decreases, very small. So hence higher order terms sc by lambda kbt square, sc by lambda kbt to the power cube, these terms will be again and again reduced. So here we neglected those higher order terms. So we found only, or we considered only, e to the power sc by lambda kbt is approximately this one for your longer wavelength, right? Why we consider longer wavelength? Because Rayleigh's law well explained the radiations of the black body at the longer wavelength. Shorter wavelength it failed to explain. So the longer wavelength Rayleigh's law is coming out from the Planck's law or not, that we are here validating. Okay, so here e to the power sc by lambda kbt, we found this one is approximately for longer wavelength. Hence equation number 1 means this one. Hence equation number 1, instead of this one we have to write how much? We have to write 1 plus sc by lambda kbt. So hence equation number 1 we are going to write u lambda d lambda equal to h pi c by lambda to the power 5 into d lambda by 1 plus sc by lambda kbt plus 1. Instead of here this term e to the power sc by lambda kbt for longer wavelength, we have been written as 1 plus sc by lambda kbt, 1 plus sc by lambda kbt. Here 1 plus 1 minus 1 got cancelled. We found u lambda d lambda equal to h pi sc by lambda to the power 5 into d lambda by sc by lambda kbt. Here lambda, one lambda is got cancelled, kbt gone to the numerator side, SC got cancelled, and finally we got u lambda d lambda equal to 8 pi kbt by lambda to the power 5 into d lambda. Let this is your equation number, and this is nothing but your religion's law of energy distribution, which supports the longer wavelength only. Okay, you go back and you can check the religion's law in the wavelength form we have been discussed, and we found the same, that is your lambda u lambda d lambda 8 pi kbt by lambda to the power 5 into d lambda, whatever we found from the Planck's law. Now we are going to derive Wien's displacement law, that is called lambda t equal to constant from Planck's law. According to Planck's law, u lambda d lambda is nothing but this one, 8 pi sc by lambda to the power 5 into d lambda by e to the power sc by lambda kbt minus 1, right? So now u lambda will be equal to d lambda you just here we cancelled out, so u lambda will be this much. So that implies u lambda can be written as here 8 pi c considered as a, here lambda to the power 5 will be moved to the numerator to lambda to the minus 5 into this can be taken to the numerator, it will be this much to the power minus 1. Let this is your equation number 4. Here this equation we consider 3, you just consider this is equation number 4, and here we consider 8 pi sc as a. To find out the wavelength at which the intensity of the spectral radiation is maximum, here we found the energy density at the particular wavelength, energy density. So this will be the maximum at where lambda m, right? You go back here, energy density is maximum where the so-called lambda m. So to find out the lambda m, what we done, that we consider that this is the maximum value, this is the maximum value for this particular lambda and particular temperature, sorry, particular temperature. So now if we are at this particular temperature this u value is maximum, then the derivative of the left side will be equal to 0 because this is maximum. Then we can solve and we can find the corresponding lambda. We done the same here. Okay, the intensity of the spectral radiation is maximum, and we differentiate the equation number 4 with respect to lambda and equate to 0. That is, we put d u lambda by d lambda equal to 0 as u lambda is maximum. Hence the equation number 4, this equation number 4 can be written as this one, derivative with respect to lambda will be, this one will be how much, du lambda by d lambda equal to 0. Now carefully differentiate this one. Here I am doing, carefully you have to watch. Okay, and also you have to write in a note carefully itself. Okay, so here we are going to use the product rule for the derivative. So here a is constant taken outside, and here two functions suppose we are going to consider, lambda to the power 5 and this one is another function, e to the power sc by lambda kbt minus 1 to the power minus 1 is another function. So first we have to consider this is your first function, put as such, then differentiate this one, e to the power h mu by lambda kbt minus 1 to the power minus 1. And we know that suppose x to the power minus n, differentiation with respect to x will be how much, minus n x to the power minus n minus 1, right? Here if I am going to consider this will be the x, so x to the power minus 1, so differentiation with lambda, first it will be minus 1 this much to the power minus 1, so minus 2. Okay, so here minus 1 e to the power sc by lambda kbt minus 1 to the power minus 2. Then differentiation of the term inside the bracket, we can found this will be here e to the power x minus 1, differentiation of e to the power this one minus 1 means only e to the power this one, e to the power sc by lambda kbt. Again as it is differentiating with lambda, so hc by lambda kbt is going to be differentiated with lambda, then it will be constant is sc by kbt and 1 by lambda will be minus 1 by lambda square. Okay, now plus this term will be is considered as first term, and we have to differentiate lambda to the power 5. So this term will be act as constant here, plus this term e to the power sc by lambda kbt minus 1 to the power minus 1. Okay, lambda to the power 5 derivative will be nothing but minus 5, lambda to the power minus 5 minus 1 is your minus 6 is equal to 0. Right, now you have to watch carefully. I have been taken common. See, here a is multiplied with this whole term, so a will be divided over here, it will be 0. Then we can take common from this term and this term as e to the power sc lambda kbt minus 1 to the power minus 1. This term can be taken common from this and this, and also here lambda to the power 5, here lambda to the power 6, lambda to the power 5 also can be taken common from this and this. So uh, so then so here you can see the terms whatever we can take common from here and here, from first term and from first and second, that is your lambda to the power 5 into e to the power sc by lambda kbt minus 1. Okay, so these things can be taken common from this first term and second term. Then here you can you can found that this is minus and this is minus, so it will be plus, and by taking common this much from whole of this one, then rest of the terms are here minus 2 minus 1 taken common, so it will be e to the power sc by lambda kbt minus 1 to the power minus 1, and this term e to the power sc by lambda kbt into sc by lambda square kbt, here minus is multiplied with minus plus. So if we are going to take this two term common from this and this, can be divide right side, it will be 0. See, one step I have been omitted, whatever I am explaining. Okay, if you want you can write in your note itself. Okay, no problem. And the second term will be here minus lambda to the power 5, and this term already taken common, only we can get 5 minus 5 into lambda to the power minus 1, that is your minus 5 by lambda. Let this is your equation number 0. Sorry, is equal to 0, is equal to 0. Okay, so now here this term taken right hand side, we can write e to the power sc by lambda kbt minus 1 to the power minus 1 into e to the power sc by lambda kbt into this term sc by lambda square kbt equal to 5 by lambda. Okay, so here it can be written as, here lambda and one lambda it got cancelled, so sc by lambda kbt written initially, then into e to the power sc e to the sc by lambda kbt, and here this term can be written as 1 by this one, 1 by e to the sc by lambda kbt minus 1 equal to 5. Right, now now we have to put sc by lambda kbt equal to x. Okay, now we have to consider sc by lambda kbt equal to x. Okay, so here if we are going to consider sc by lambda kbt equal to x, then this equation will be x into e to the x divided by e to the power x minus 1 equal to 5. Right, so it will be, we get x into e to the x by e to the x minus 1 equal to 5. So that implies it can be written as, here first you divide e to the x with numerator and denominator, we can found x divided by, I am going to divide this with numerator e to the x means it will be 1, again with this term it will be 1, with this term if I am going to divide e to the x then it will be e to the minus x, okay, equal to 5. So here this can be written as x by 5 equal to 1 minus e to the minus x. Just 5 taken this side, this will be take this side. So it will be x by 5 plus e to the minus x equal to 1. This equation has two roots. If you are going to be solve this equation, you are going to get two roots. X will be 0 and x will be 4.966. You just put x equal to 0, e to the 0 equal to 1. Here e to the x equal to 0 will be 1. Now if you are going to put e to the power approximately 0.5, e to the minus 0.5, and here 0.5 also you are going to calculate, it will be 1, and this equation has two roots. So equation has two roots. So if we are going to consider uh, x value is this one, 4.96 is a constant, then x equal to sc by lambda kbt. So sc by lambda kbt will be equal to 4.96, okay, and this value found by considering maximum value of u lambda. So this value, how we found? We found this value equal to this much when we consider the lambda is maximum, where your u lambda is maximum value. So differentiation of u lambda equal to 0. So here as we considered that maximum u lambda, so corresponding lambda will be written as lambda m, right? So this 4.96 will be written as sc by lambda m kbt. So lambda mt equal to sc by kb into 4.96. So sc constant, c constant, kb constant, this is also constant, let this is constant, another constant b. So lambda mt equal to b is the form of Wien's displacement law. So hence in this way we also derived Wien's displacement law from Planck's law. Now we are going to go for the Stephans-Boltzmann law, that we are going to derive the Stephans-Boltzmann law from your Planck's law. And according to Planck's law, in the form of frequency, that is your u lambda d lambda equal to 8 pi mu square by cq into d mu into h mu by e to the power h mu by kbt minus 1. You go back to your note. Last class we found that your u mu d mu equal to this much. The same thing have been written over here. And total energy, if we are going to find out, then we have to integrate both the side. This will be represented as total. This is energy density in the frequency range mu and d mu. If we are going to consider all the frequency range, then it will be your total energy, right? The total energy will be equal to 4 pi h by cq. So here total energy density, okay, because u mu is represents the total energy density in the frequency range mu to mu plus d mu. So if we are going to consider whole range of frequencies, so this will be the total energy density, and it will be integrating over 0 to infinity considering all the frequency range. So 8 pi h by cq taken outside, 0 to infinity, e mu to the power q by e to the power h mu by kbt minus 1 into d mu. Now we have to consider h mu by kbt as x. So mu will be kbt by h into x. So d mu will be kbt by h into x. Now we have to put mu and d mu in this equation number 6. Now the equation number 6 will be 8 pi h by cq, 8 pi h by cq, 0 to infinity, because limit is not going to be changed. If x is going to be, see, if frequency is 0, x is 0, if frequency is infinity, so x will be also infinite. So 0 to infinity, here instead of mu, that we have to write kbt by h into x. So kbt by h into x whole cube into d mu is nothing but your kbt by h into dx. So instead of d mu, we have to write kbt by h into dx whole divided by e to the power x minus 1, e to the power x minus 1, because here h mu by kbt is considered as x, so it will be e to the power x minus 1. So here you can see that kbt by h cube, kbt by h, so it will be kb to the power 4, t to the power 4, h to the power 4. Already this constant is here, sorry, 8 pi h by cq, kb to the power 4, t to the power 4 by s to the power 4, and integration of 0 to infinity only x cube by e to the power x minus 1 dx. So by integrating this one here, I am not integrating this one. If you can integrate this one, you can found pi to the 4 by 15. Okay, so here we found that total energy equal to 8 pi kb to the power 4 t to the power 4 hq cq hq into pi to the power 4 by 15. Okay, so now E will be equal to 8 pi to the power 5 kb to the power 4 t to the power 4 by 15 cq hq, or this much can be considered as a constant, sigma equal to this much, so E equal to sigma t to the power 4. This is nothing but called as your Stefan's law. So here in this lecture we have been derived all the laws which explained the black body radiation classically. Those laws has been derived from Planck's law. Okay, so hence Planck's law is one of the universal law which explains both the higher frequency range radiations from the black body and lower frequency range radiation of the black body, lower frequency side radiation of the black body. So here we derived all the laws from Planck's law of radiation. Okay, so thank you so much for watching this video. Write down, pause the video and write down the note perfectly. And the next class we are going to be discuss Sahaj ionization formula. Thank you so much for watching this video. Thank you.